Good day guys, welcome to MSTC online tutorial. So in this video we want to show that xjn prime of x equals to minus njn x plus xjn minus 1 x. So now the first thing we need to know is the formula for jn of x, which is summation r equals to 0 from equals 0 to infinity minus 1 raised to power r over r factorial n plus r factorial times x over 2 raised to power 2 r plus n. So now the first thing we need to do, the first step, so I'll be listing them in steps. Step 1, what we will do is to differentiate. Now if we want to differentiate this, you will see that every other thing here is a constant because they are not carrying x, so it's only this place that I have my x. So I will differentiate that side using our function of a function. Now let's see. So I will have jn prime of x equals to summation, they will remain the way they are because they are constants, over r factorial n plus r factorial. Now when you are differentiating, you know the power will come down, 2r plus n. Now it will multiply back, x over 2 raised to power 2r plus n. I will remove what? 1. Then I will multiply by, because I'm differentiating, this is a function of a function, I will now differentiate what is inside the bracket. If I differentiate what is inside the bracket, I'll have 1 over 2. Good. Now step 2 is to multiply both sides by x. So if I multiply both sides by x, I will have x jn prime of x equals to, I'll multiply it behind, so I'll have this repeated, minus 1 raised to power r 2r plus n over r factorial n plus r factorial. This will give me times x over 2 2r plus n minus 1 multiplied by what? X over 2. Now I haven't done that. The next step, step 3, is to rewrite what you have in this bracket as minus n plus 2 into r plus n. Now let me show you that, how to remember easily. You have, check this explanation box, you have 2r plus n. So what we just do is factor out 2. If you factor out 2, you will see that this is 2 into r plus n. Normally, mathematically, we're supposed to say over 2 so that it will be the same thing. But then we ignore it because of what we want to get. I'll now say minus n. I'll subtract n from it. Now let's check. Open up the bracket. You will see 2r plus 2n minus n, which is the same thing as what? 2r plus n. Are we good? You see that this and this, they are equal. So now we'll bring that into this bracket, but we are going to write it as minus n plus 2 into bracket r plus n for convenience sake. So I'll rewrite xjn prime of x equals this repeated, minus 1 like this, my denominator r, this, n plus r factorial. Now this bracket I want to change, we now write it as minus n plus 2 into bracket r plus n from the explanation we did earlier. So you close your bracket, you still have this multipliers over this 2r plus n minus 1 multiplied by, let me write it this way, x over 2. Now the next step is to open up this bracket using this simple logic. You know, if you have a plus b over c is the same thing as what? A over c plus b over c. Are we good? Okay. So now that's the next step, which is step 4. We might decide not to even call it a step because we have already explained it here, but then let us write it as step 4 for us to remember easily. Step 4. I will rewrite this. Take note that this is multiplication. That is, this one is multiplying this. This one also is multiplying this. So you will open up the bracket one after the other. Now let's go. Don't forget that they are all multiplying this bracket. This, they are all multiplying the bracket, and you are going to use this law to separate what the fraction. So now let's go. I will have here summation from r equals 0 to infinity minus 1 raised to power r. Now I'm multiplying with minus n. Take note. Let me put it here, minus n over r factorial n plus r factorial. Now this also is multiplying. Don't forget, this is multiplying. Since this is multiplying, let me use this from here. If I say this is x over 2 times, they have the same base. Using the law of indices, here, you will see that, okay, using the law of indices, let's do that here. You will see that x over 2 raised to power 2r plus n minus 1 plus 1. So this minus 1 will cancel this plus 1. So what I will have here is multiplied by x over 2 raised to power 2r plus n. That's for the first bracket. Now plus the second one, which is plus 2 into r plus n. So I will open up the bracket again the same way I open up this one. It will be summation r from 0 to infinity minus 1 raised to power r. Now it will be 2 into r plus n. Don't forget that we have separated the fraction now. I will close this over r factorial n plus r factorial. Now watch what we want to do here. So here I'm not going to use the law of indices the way I did earlier. I will not use it because I need it to work for me here. So I will close this bracket. Now multiply by x over 2 raised to power 2r plus n minus 1. Now times, look at it, let me write it out, x over 2. I'm not using the law of indices, so these two, we cancel these two. Now I'm left with 1x, so the x will come here. Now let us observe this. This is equation 4. You know what is on our left hand side, that is xjn prime of x. In order not to waste time, that's why I did not write it. So now look here rather, see this formula. What is it? Let's check. Summation r equals to from r0 to infinity minus 1 raised to power r minus n over r factorial n plus r factorial. Now look at it. The only thing that is there is this minus n. If I bring out minus n, you will see that I'll be left with my my jn of x. Look at it from here. So let me bring it out. I'll have minus n so that we will all see it. R this minus 1 r over r factorial n plus r factorial, and this one will be times x over 2 2r plus n. Now this, let me complete this, plus, now these two has cancelled these two. Now this my x that I did not use, I'll bring it out. I'll say x summation r from 0 now minus 1 raised to power r. Now please watch closely. R plus n times x over 2 raised to power 2r plus n minus 1. So I haven't done that. What about the denominator? The denominator will be r factorial n plus r factorial. So we are coming to the end of the proof gradually. Now just take a close look at this. From here is my what? Jn of x. So let me just write this minus n, this because minus n is multiplying, jn of what? X. So plus, now we want to do a simple arithmetic here. X. Now let's come to this place. This is r plus n and this is r plus n factorial. You know that n plus r is the same thing as r plus n. So now let us check this explanation box so that we will know what we are doing there. You know that we know that n plus r factorial is the same thing as what? N, okay, let me write it here. It's the same thing as n plus r times n plus r minus 1 factorial, because it will continue to decrease by 1. So instead of writing this n plus r factorial, I will put n plus r into n plus r minus 1 factorial, so that my r plus n, we cancel r plus n that I have here, because if I put this here, this r plus n, we cancel this what? R plus n. So that we now have, please watch, that's the last step. R equals to 0 minus 1 raised to power r. Now this has cancelled this from the explanation, and we are left with x over 2 raised to power 2r plus n minus 1 over r factorial. Here it will be what? We said since this has cancelled this, we are left with what? N plus r minus what? 1 factorial. So this place will be n plus r minus 1 factorial. So to now write the final answer, you don't forget that we have xjn x from here, so I'll bring it back. Have xjn prime of x, which is equal to minus njn of x plus x. Now let me show you something. You see that the only difference here from the normal jn formula is that we are removing 1 from anywhere we have what? N. You see, initially there was no minus 1, but now we are removing 1. Look at it. Initially there was no what? Minus 1. It was n plus r factorial, but now we are removing 1. So that is why my jn will become jn minus 1 of x. Thank you very much for watching. Don't forget to share with your friend. Click on the subscribe button and make sure you like this video. Subscribe to our channel so that you get more solution. Thank you very much for watching.